Okay, real quick, want to look at some of the difference in properties between ionic and molecular compounds. So you can try to use some of this information to figure out if a compound is ionic or molecular. If you don't know its formula, you can do it by physical properties in general. To start with, ionic compounds. One of the things you want to understand about ionic compounds is that they are always crystalline solids when they're at room temperature and pure, when they're not mixed with anything. Okay? They're always crystalline solids, all ionic compounds. So if you're looking at something and you see crystals, tiny little crystals, almost always going to be an ionic compound. Now there are some molecular compounds that can sort of disguise themselves as crystals, but for the most part you're talking ionic compounds. Remember, crystalline solid means it's three-dimensionally repeating pattern of ions. Ionic compounds, because they're solids at room temperature, they typically have very, very high melting points and boiling points. Okay, the ionic compounds that you will encounter, you have to heat them up to tremendously high temperatures, 1,000 degrees or so, or more, to get them to melt, and even higher to get them to boil. They are made of ions, though, oppositely charged particles that are just sort of stuck together because they're oppositely charged. What's really neat about ionic compounds is if you put them into water and dissolve them, that causes the ions to separate. Ions have an electrical charge to them. If you melt an ionic compound, it also causes the charges to separate. The minute those charges separate, that liquid, either the solution or the liquid ionic compound, becomes capable of conducting electricity. We call these substances electrolytes. So the definition of an electrolyte is a substance that will conduct electricity when in a solution or when melted. Ionic compounds that contain transition metals often have very bright colors, and you've seen some of those: nickel or copper or manganese. Compounds that contain those transition metals, ionic compounds, will often be very brightly colored, blues and greens and reds and yellows. Okay? Now, molecular compounds, by contrast, since they're not made of ions, they're made of molecules. Molecules don't split up when you put them in water, and they don't split up when you melt a molecular compound or get it into a liquid state. So these don't conduct electricity. They're non-electrolytes. Usually molecular compounds are liquids or gases at room temperature. Okay? They're generally not going to be solids. If they are solids, they're usually amorphous. Now, the possible exception that I could think of would be things like sugars. Okay? Glucose and sucrose are actually molecular compounds that are solids, and because they're crystals, they sometimes look like ionic compounds even though they're molecular. Most molecular solids are amorphous. They typically have very low melting and boiling points, which is why they're gases or liquids at room temperatures. They've already melted or they've already boiled by the time you get to room temperature. And a lot of these molecular compounds will have a strong odor, and most especially if they contain sulfur. So these are just some ways that you can identify molecular versus ionic compounds. Molecular compounds don't split into ions when you put them in water. Okay? These are, again, very general, and there are going to be exceptions. With the only thing that doesn't have an exception, the only rule that doesn't have an exception, is that ionic compounds are always crystalline solids when they're pure at room temperature. But all these other ones, you might find exceptions to them. For the most part, it's pretty easy to tell whether or not a compound is molecular or ionic by looking at its physical properties.